Today, we're diving straight into it and getting hands-on configuring access ports, trunk ports, and ether channels, the core pieces that make up your switching topology. And we're starting with access ports because if your devices can't join the network, nothing else matters. Let's dive in. Before we jump into any configs, let's talk about what access ports actually do on a switch. An access port is a layer 2 interface that belongs to one VLAN. Its entire job is to connect end devices such as PCs, printers, IP phones, and access points to the network. When a device sends traffic into an access port, the switch treats it as untagged. It doesn't expect any VLAN labels from the endpoint. The switch then places that traffic into the VLAN the port is assigned to. And when the switch sends traffic back out to that device, it also sends it without tags, because end devices don't understand 802.1q VLAN tagging. So in short, access ports are the clean handoff between your endpoints and the VLAN they live in. They keep traffic organized, devices isolated where they need to be, and form the foundation of your entire layer 2 design. In our lab topology, we'll configure the links that connect directly to our end devices as access ports. Each of those ports will be assigned to VLAN 10, which we're using as our data VLAN. This gives all endpoint traffic a clear, untagged path into the correct VLAN. Now let's talk about trunk ports, because these are a huge part of how switches move VLAN traffic around your network. A trunk port is a switch interface that can carry multiple VLANs at the same time. Unlike access ports, which only handle one VLAN and send untagged traffic, trunk ports use 802.1q tags to label each frame so the receiving switch knows exactly which VLAN it belongs to. This is what allows VLANs to stretch across multiple switches and stay separated the whole way through. You'll typically use trunk ports between switches, routers, firewalls, or anywhere you need more than one VLAN to travel over a single physical link. They're basically the highways that keep all your VLANs connected across the network. For this next part of our lab, we'll start by creating a new VLAN on both our access and distribution switches to use as our native VLAN, since we don't want to rely on VLAN 1 being the default VLAN. After that, we'll configure the trunk ports between our access and distribution switches so VLAN 10 and 20 can travel across those links. Once branch 1 is fully configured, we'll run a script of the exact same command set on branch 2 to keep both branches consistent and aligned. Now that we've finished configuring our access and trunk ports, let's take a moment to look at a feature that adds both strength and efficiency to our switching environment: EtherChannels. If you've ever looked at multiple links between two switches and wondered why can't they simply operate as one, EtherChannel is the technology that makes that possible. Instead of treating each cable as an independent path, we bundle them together so the switches view them as a single logical connection. This gives us increased bandwidth, improved stability, and redundancy, all without spanning tree disabling half our links. The process is straightforward. As long as the member ports share the same characteristics, speed, duplex, and VLAN configuration, they can participate in the channel. Whether we use LACP, PAGP, or manually configure the channel in on mode, the end result is consistent: multiple physical links working together as one resilient, unified interface. EtherChannels are common in real-world networks, connecting access to distribution to core, and even linking switches to high-performance servers. Once you understand how they operate, the overall network design starts to feel more deliberate and far more reliable. For the final part of this episode, we're going to aggregate the links between our distribution switches into PAGP-based port channels. Once those interfaces are successfully bundled, we'll configure the port channel as a trunk, using the same trunk configs we applied earlier in the lab. With these port channels in place, our distribution layer becomes more resilient and better aligned for the next step. This configuration sets the foundation for our upcoming HSRP setup in the next episode, where these aggregated links will play a key role in providing gateway redundancy.